A logarithm is just a special way of asking a specific question. Okay, so we're going to look at how to write an actual logarithm. So the way we would write it is like this. And so you'll notice a logarithm has a subscript number. The way you would read this is log base b of a is x. And so the specific question that we're looking at is what exponent is required to go from a base of b, this base of b, to reach a value of a, or this value. So it's saying what exponent is required to get this base number to equal this number. So exponential form that we've talked about before, you would see it as a base to an exponent equals the answer. In logarithmic form, it's going to say log to a base, then it's going to have the answer equals the exponent. So the way you can kind of remember this is the base is in the basement, down low. The answer starts with A goes next to B. Exponent starts with an E, like equals, so the E's stay together. It's a little bit confusing, first time you've ever seen that. So on the inside of that foldable, I think I just closed it actually. Time out. You have this loop-de-loop. And oh no, my logarithm has no base. So on the my logarithm has no base, we're gonna just say anytime the base of a log is not written, it is assumed to be the number 10. So for example, if you just saw log 10, that really means log base 10 of 10, which log base 10 of 10 is going to equal 1 because 10 to the power of 1 gives you 10. Or if you said log 1,000, that really means log base 10 of 1,000. So 10 to the third power gives us 1,000. So we'll practice some more in actually evaluating logs in just a second. Now we're going to do the loop trick. It's how we get from log to exponential and back. So the loop trick, we start at the base and we draw a loop counterclockwise. So this would be our first, second, and third stop in that loop. So same if I'm going this way, start with the base, counterclockwise, this would be first, second, and third stop. So if we had log base 4 of 64 equals x, and we are going to rewrite that as an exponential equation, we would do our loop here to here to here. So first, second, third. So we would start with our first number as our base to the power of x equals 64 because it's 1, 2, 3. If I was starting out in exponential, I do that same loop. So 1, 2, 3. So I would write log base 343 because that's my first number stop of 7, that's my second number stop, equals x, which is my third number stop. So we'll practice that a little bit more on this next. So on your actual notes, it'll look like this. We already went from logarithmic form to exponential. Exponential is b to the power of x equals a, or the answer. And so we're going to just practice converting from logs to exponential form. So using that loop trick, we would do 3 squared equals 9. This one, we do that loop trick, 7 to the power of 0 equals 1. Do the loop trick, 4 to the power of negative 2 equals 1 over 16. So that's going from log to exponential, so we use that loop. When we go from exponential to log, we're still going to use that loop. So we're going to go from here to here to here. So we're going to write log base 14 of 196 equals 2. This would say log base 12, because it's our first number, of 12 equals 1. This one is log base 2 of 1/8 equals negative 3. So that's how we use the loop trick to convert exponential to logarithmic. The common logarithm is actually what we wrote on that other page. If it has a base of 10, it can just be rewritten without that base showing. So if it's not there, it's assumed that it's a 10. So now we're going to evaluate them. So this, when we evaluate, we're actually seeing like what would it equal. So if we used our exponential, it would be 7 to the power of x equals 49, or 7 to the second power equals 49. This has a base of 10, so when we rewrite it, it would be 10 to the what power equals 100. Well, 10 to the second power equals 100. This is saying 2 to the what power equals 64. Well, 2 to the sixth power is 64. And then the last one we're going to look at, well, one of the last ones, is this one. We would rewrite it as 9 to the what power equals 1 over 81. So we know that 9 squared is 81. And since it's a fraction, we know it's going to actually be negative 2, because that's how it would flip to the bottom. But I want you to look at number 20. This would be 64 to the what power gives you 4. So you know that this is actually going to end up with a radical. And so we know that 64 cube root of 64 is 4. So instead of writing as cube root, we could write it as 4 to the 1/3, or 64 to the 1/3. So that's how we got a fraction. So remember, whatever the index is, that's the bottom of that fraction. And so we're going to save change of base for a different time. Just wanted to do a quick intro of logarithms.